I wanted to open up with one of my favorite quotes. Teaching is the one profession that creates all other professions. This is a quote I found a while back when I was heavy into music, and then as I got more older, the more true it became. So I want the intention of this talk to be that we should try to do as much as we can to share the knowledge that we have with the folks who are seeking to learn, because you'll never know who you'll inspire. With that said, I am not a certified teacher. I never got a degree. I didn't even graduate high school. But somehow I've still taught at least 100 classes in various topics such as music, guitar, sight reading, singing, a little bit of cello, a little bit of bass, dozens and dozens of music lessons. I've taught folks plenty of party games and party tricks. I could show you how to open a beer with pretty much anything. And I've also taught the importance of focusing on the task at hand when your surroundings are distracting you. And one of the common things I hear is that I am a pretty good mentor. But what is a mentor? According to Webster, a mentorship is a relationship in which a more experienced or more knowledgeable person helps to guide a less experienced or less knowledgeable person. And I feel like that is all life is in most interactions. We've all done it. We've all helped someone get unstuck with our wonderful wisdom. I often wonder sometimes how my mentees get into some of the technical situations that they get themselves into. And I end up laughing a lot. But at the end of the day, my goal is to help them get unstuck. You don't have to be a senior, is this point I really, really want to stress. Sometimes it's better to learn from folks who are just a little bit farther along than you, since their experience is going to be generally more relatable. You don't have to be a pro, master, an expert, a senior to help create a class that'll bring value into someone's life. I know from my experience in teaching music that I didn't have to be a pro to be helpful. I didn't have to be Jimmy Page to teach a C chord. So if you're interested in teaching a class, I encourage you to do so. So how did I get started? I went to this school called the Turing School of Software and Design in Denver. It's great. Highly recommend it to anyone interested in starting a career in web development. They have these try-coding classes a few times a month. These try-coding events usually happen 3 to 6 times a month, just depends. And I sign up to be a teaching assistant every opportunity I can. I've been doing this for almost 2 years now, and I try to do it a couple times a month. These classes are a basic introduction to how the web works, and we go over basic data types, some DOM manipulation. We go over a little bit of Ruby, a little bit of JavaScript. And these classes are generally 5 to 6 hours, depending on the events, with a little lunch included in there. And I've done over 100 of these, and you'd think after doing over 100 of these, I'd be bored out of my mind teaching the basics, but that is not the case. I still find myself learning new stuff in these tri-coding events because people ask interesting questions, such as, why do sharks want to destroy the internet? This is a real thing. And this question comes up every couple of months. In short answer, no one really knows. But an idea that's been floating around is that sharks can sense the electromagnetic fields in the cables, which makes them curious. Or some folks think it's food. Nobody really knows. Another question that comes up is, when will the machines take over? Which I usually respond with probably right after they win the World Cup. Another big question is, how do computers even work? I get this one a lot, and it's a hard one. Even if you know the details, you still have to translate the concepts and ideas in a way that's easily understandable. So my go-to answer for this one is always aliens. I won't tell them it's aliens, but I'll tell them it's aliens. So every class is a little different. I get to practice explaining things to folks who are unfamiliar with the terminology, and I think that's super fun. But what I enjoy the most is taking notes on what the instructors are doing. How are they keeping the classes engaged? How are they keeping the students engaged? Between the two instructors that normally run these classes, they have at least 20 years of actual teaching experience. So I've learned a lot from them in terms of logistics, curriculum building, how to read a room, and most importantly, having clear goals about what the students should walk away with after the class and how to communicate those goals. So for today's tips, these are things I've just learned that have helped some of the classes I've been in run smoothly. And some of the tips are going to be make sure people are interested, define your goals, ask for help, how to do that, agenda over curriculum, real world examples and how to use them. Tools are important. Use your TAs, and lastly, avoid gatekeeping. So let's go. How does Elixir come into this? Well, I was running Elixir at Turing, and there wasn't really anyone to talk to about Elixir. So I had to teach folks what Elixir was, introduce them to it. I was doing small little exercises with folks and just small little projects using Phoenix with some people in my cohort or folks from other classes. And eventually a buddy of mine, Michael Cohen, started having these Intro to Elixir classes at Turing. And I was totally in. And apparently so was a lot of the school. There was a great turnout for these Intro to Elixir classes. People were having fun. I believe on average there were 15 to 20 students attending these, so I knew there was interest. And eventually Michael didn't have enough time to keep running the classes, so I took over and started thinking about how I could incorporate some of the things I had learned from Tricoding. So this brings us to hot tip number 1. Make sure people are interested. You don't want to start working on something that no one's going to be interested in, because it's never fun to host a party and have no one show up. But I knew folks are going to be interested in these Elixir classes because I'd seen it. So after I knew I would have attendees, I started getting to work on figuring out how to actually put this class together. So I start off with what I learned from Tricoding, and that I really should start with defining my goals should be one of the first things that I do. So my goals were to refine my understanding, practice teaching, help folks with their job hunt, and to network. I also think about what the student goals might be, and I'll ask attendees, people who are interested in these classes before the event even begins, a couple of weeks beforehand. I'll ask them what their goals are, and usually it'll be they want to land their first dead job, they want to learn a new paradigm/pattern, and networking. So trying to figure out a way to touch on all of these generally tends to help. And also, what are your teaching assistant goals? So you should have teaching assistants, especially in the remote world that we live in now, and I'll explain why later. But ask them what their goals are. Like sometimes they just want to give back to the community. Sometimes they are offering long-term mentorship and they want to be able to provide that. And sometimes they just want to network, which is fine. So brings you to hot tip number 3. Ask for help, especially if you're not sure what you're doing. Find someone you could ask questions to. Also ask around your community and see if anyone's interested in being a teaching assistant. But where do you ask? Well, some of the places I like to look are in the Elixir Slack channel. I will ask local meetup groups. I'll ask my old teachers, professors, instructors, because they know how to teach. I'll reach out to different tech schools, different boot camps, see if anybody's interested in attending or helping out. Sometimes I'll even just ask coworkers, and that generally tends to work out. I like to offer folks coffee gift cards for donating a Saturday, and that tends to work out pretty well. Next big one is agenda over curriculum. This is where I start talking about a little bit of the class material itself and how I came up with the curriculum. I find it's easier to start off with an agenda and to try to follow that more rigidly than the curriculum, because every class is a little different. So how much material you cover can vary depending on the questions that are asked. So I find it a lot easier to just focus on the concepts and the agendas versus the details of the curriculum. And these classes, the ones I run, are usually 5 to 6 hours long. So I can't touch on everything, but these are just some of the things I found to be most useful when trying to introduce functional programming concepts. So I like to start off these classes with a little history lesson. Since the majority of attendees that are attending have generally only worked in object-oriented, I start off with a history lesson and I go over how OOP came to be and why it was created. And if you don't know, object-oriented was created to deal with a very interesting inventory problem involving freight ships. They had to figure out a way of tracking all the containers, their owners, any damages, who was liable for what, how much fuel was going where, There's a lot of things they had to keep track of. And the old paradigms like functional, procedural, all those didn't really lend themselves well to handling this problem. So they had to come up with a new one. And the language that ended up becoming the solution was small talk, and it was created specifically for this problem. And an interesting thing that ends up happening with a new paradigm is that a lot of the tools that are available in object-oriented don't really carry over retroactively to older paradigms. So you can't really bring the concept of like an instance variables or like state and use some of those same tools available in like older paradigms. But with that said, you can take some functional concepts and use them in object-oriented, and it'll make your object-oriented a little bit better. After I'm done with the object-oriented lesson, I go into a 2-hour explanation on the origins of functional programming using lambda calculus. I introduce them to a wonderful individual known as Alonzo Church, and we have a fun old time. But I am just kidding. I just generally like to introduce the history of functional programming with a Rube Goldberg machine to show how the state or energy of an application can be passed along, how an original action can start off small, but as the energy or state moves along the application, you can see how something small can have a big effect on an application. I spend about 15 minutes on this history lesson and leave 5 to 10 minutes afterwards for questions. And the TAs tend to be very helpful for this portion. I try to have at least 1 or 2 teaching assistants that are way more knowledgeable than me. So if I get a tough question, they could explain the details that I miss. So a next big concept that I like to go into, especially early on, is this really diving into this idea of what is the difference between a function and a method. So for those who don't know, a function is a behavior that acts on data or an input, and a method is generally used when your data and your behavior are tied. So as I said, methods hold state and behavior. So for example, we have a string we have a string of string on the left, and we have a dot split. That dot notation is us invoking the split method that is tied to that instance of the string class string. And then we end up with a split string in an array. It's great. Functions behave a little differently. Functions are behaviors that act on inputs. So we would have a string module that we would invoke a split function, but we would pass the data in. And I really like to spend at least a half hour or as much time as needed to just like drill down into these concepts of like, why is a function different than a method? Why do we split up our data and our behavior? Why do we couple up our data and behavior? And just doing a little deep dive on that really generally tends to help later on for when we're actually working on code challenges in Elixir, because they won't have access to methods. So it generally tends to help. Another big concept I like to go into is this whole concept of declarative versus imperative programming. And I started off with 2 questions. What do these concepts mean to you? And what tools you use that already fall into either one of these categories? This is interesting because normally people will ask, well, what is imperative? What is declarative? Which I like to respond with analogy of the Uber driver instructions. So if you were going to give imperative instructions to your Uber driver, that might look like turn right on some street, turn left on some street, go through these lights, drop me off somewhere. The declarative approach would be just telling him to bring you home. You don't care how they do it, just as long as they get you there. Believe it or not, this whole declarative versus imperative is one of the hardest concepts I have found to get folks to be okay with. The idea of being okay with not understanding everything that's going on. And this was a hard thing to try and figure out how to teach or how to get past or how to not make as big of a blocker for folks. And it wasn't until I started using examples of things that they are currently using that fall into either one of these categories, such as API calls, for example, is something I like to use. When you make a GET request, you don't really care what's happening underneath the hood. You generally just care about what the response is going to be. This is very declarative. You declare what you want and then you get it, versus hand-rolling your own HTTP client from scratch, which is just kind of a pain. Having people be okay with not understanding everything is a common hang-up, but like I mentioned, showing them or pointing out tools they already use that are declarative versus imperative tends to help with the transition. One thing I like to point to is using a map versus a for loop. They both kind of do the same thing, but you don't have to see all the individual steps of the map to know what it's doing. You just know that it's going to do something, it's going to give you a response. Next type of deal I like to go into is everything being reduce. I like to do a deep dive on reduce and what it does, how it works. I find it is very important to go into that because it is one of the backbones of programming, just reduce in general. I'll also give them a little intro into some of the other enumerables, reduce, map, filter, zip. These are the backbone of most functional programming enumerables, so you could accomplish 90% of what you need to with just these alone. Next bit I'll go into, or would go into in a curriculum, is state being immutable, and really going and doing a little deep dive on why there are no instance variables, no concept of this for the folks coming with a JavaScript background. And I'll spend 20 minutes on this and leave some time for questions because it tends to be very useful for later on. And right after that, I'll explain some of the benefits. You generally only have to worry about your inputs and outputs. It's easier to debug, and it's generally faster in a lot of different ways. I go into deeper details on this during the class, but I got to keep going. So next comes the intro to Elixir. I used to start off teaching Elixir and then going into paradigming or into the concept of functionals programming, but I realized that folks didn't really feel like they were walking away with practical information. Sure, Elixir is cool, but how is it going to help them get their job? I found it more useful to explain the functional concepts first, then having them use Elixir to practice what they've learned. And that's the first half. I'll start introducing Elixir, so why companies use it, where it came from. I'll introduce them to data types and hex docs. And the next big thing that I like to focus on is pattern matching and multi-clause functions, because that seems to be a big blocker for folks. And it's not so much understanding what it's doing, but I feel like it's trying to figure out or showing them situations why or how it can be useful. So this is what we normally see when we look up like examples of pattern matching. We get the X is matched to 1 or 1 is matched to X. And then you see this one and it's like, well, that's wild because normally that would break other languages, but it doesn't in Elixir. And then every now and again, you run into this diagram where we have a pattern on the left, the match operator on the center, which is the equal sign, and then a value on the right. This sort of thing starts to make sense when you're working with Elixir for a little bit, but I wanted a way to show the usefulness before they even got started playing around with this. So I came out with an example that's been working pretty well. It's a real-world example. So this is a little validation exercise I came up with. So you have a user, you need to write a program that validates the user based off their age. Now I'll introduce them I'll start using some of the data types. So we have a map over here, we have a variable, and how we access values in a map the other way. And then I'll go into how you access values in a map the Elixir way, using some pattern matching. But folks are still wondering, okay, why is this going to be useful? Well, that's where I'll just keep going and showing them what happens when you aren't using pattern matching, and how you can get yourself in some pretty interesting situations and end up with a lot of nested if statements. So we're trying to validate this as users over the age of 18. Cool. We're just going to pull out the value and pull out the year that they're born and compare it. And if they're over, it's true. And if their age is not over a certain age, then they're not. That works out. We have a couple of different users up there. This works. It's pretty easy to follow, but what happens if you have a user that never provided a date of birth? Cool. The answer is just write more code. Write another if statement. If the year born is equal to nil, do false, and then you just keep going with the other logic. Awesome, that kind of works. But what happens when we get the wrong data type? We get a string instead of an integer. How do we handle that? Well, the answer is write more code, more if statements. Currently, this piece of code has 4 if statements. I wrote it. It's hard to follow. I am not a fan of doing this. I try to avoid if statements or nested if statements as much as possible. And this generally leads to interesting questions. I will ask them how they can make it shorter without knowing any of the pattern matching stuff. And they come up with some interesting examples. But then I'd start introducing this concept of the multi-clause functions and how you could have certain functions be triggered or start off based off the shape of the data that's being passed in. So it'll match on the arguments being passed in. So if this date of birth is nil, we're going to do false. If the year is nil, we're going to do false. And then we have a couple of edge cases. This is a lot easier to reason about than this, in my opinion. And just showing them that little example tends to help. Trying to figure out useful real-world examples generally tends to help a lot with these situations, or when you're trying to explain these like really abstract ideas. This is one that I find works really well for explaining pattern matching in multi-clause functions. Then I'll go through, I'll show them some notes, and I'll just spend a little bit of time just like really dissecting what's going on. And that's the general curriculum. By this time, we're about 2 or 3 hours in. Folks are tired, so we break for lunch. And then when we come back, it is time for technical challenges, because at this point, they're really antsy to play around with the language and to practice code challenges. And surprisingly enough, they do pretty well. Since we spent the beginning of the class teaching the fundamentals, the questions went from why isn't this working to, oh, is there a tool or a enumerable or a pattern that can help me do this? And usually I just point them to reduce. So last couple things. Your tools are important. REPL.it is amazing. It's about as low entry as it gets. You don't need IDE. Your students don't need an IDE, which means you don't have to spend time debugging environment issues, and it's easy to share code between folks. Some of the good tools out there for your screen sharing, Zoom is great. They have this feature called breakout rooms that you can use with your TAs. So if somebody gets lost, somebody joins late, somebody's super stuck, or someone needs help debugging something, you can pair them up with a TA in a breakout room while you continue on with the class, and they can work it out amongst themselves. Slack is also pretty good, but it's very limiting. I would generally only use it in a group of 2 to 4. The big downside to Slack is folks generally have to be within your workspace in order for you to invite them into the call. So I generally would use that for, I don't know, internal trainings, something like that. And then tuples, very great. The downside of tuple is that it's only for 2 people, as you might be able to tell by the name. It is a tuple. But it's by far my favorite. Very lightweight, very fast. Allows remote access, so you can take over people's computers and help them debug stuff or help them with their projects. It's great. Hot tip number 7, use your TAs. So have them respond to things in the chat and encourage them to communicate in the chat with your attendees. Have one who is willing to take over if connection drops. This is very important. If you have a class of 20 people and they just took a Saturday off to be in your class, if your connection drops and there's no backup plan, it's going to be a real pain to get folks to reschedule, especially between TAs, the folks who are attending. And also by that point, folks just might not be that interested because they had a bad experience. You want to use your TAs and try to pair them up with folks who are lost, new, or super curious. Send them off in those breakout rooms, and also rehearse your agenda with your TAs. So if your connection does happen to drop, they're not entirely in the dark, or they're not entirely lost on what to do next, because you've taken 20, 30 minutes, a couple of days before the class to just like run through and just talk about like different possibilities, what the learning goals should be for every point on the agenda or every concept in the agenda. So, and finally, I would like to say, I think there's a big one, avoid gatekeeping. It's kind of simple, like avoid Vim. Don't try to get folks in an intro class using Vim. Avoid GitHub. They don't need to know GitHub to start learning the intros of a language, especially if they're super new. But even if they're not super new and you're introducing them to like a new language, say they've coded for a year or two, like they still don't need GitHub, they still don't need Vim. Make it as easy as possible for folks to participate. And with that said, keep to the goals. Your TA goals, student goals, your own. If you have a class coming up, spread the word with your community and ask for feedback after your class. Then try another one. The first one might not be perfect, but nothing ever is. Don't let perfect be the enemy of the good. And by that, I mean is that you shouldn't wait for the perfect time or situation to start something that could be a good experience for others. If you wait for everything to be perfect, you'll always be waiting. And that's my talk. Thanks for listening. And any questions?
Great, thank you, Melvin. That was a clever idea to record too, I think. How is your connection right now? Is it good to take questions?
Yeah, I should be good for questions as long as I keep my video off.
Great, got it. Well, we have, it looks like we have 2 questions so far, and then I have some, and others just type them into the tab as we're going along. So first I'm going to ask if David can unmute and ask his question.
Right. So at the beginning, you were saying that agenda is better than curriculum, but I didn't understand how that is, what that actually means in this context.
Gotcha. So in a curriculum, you might get super detail oriented, like, all right, I want to go into map, I want to go into reduce. But depending on the questions that they ask, you might not even touch any certain parts of the curriculum. So I'll have like a concept in the agenda, such as like, we're gonna go into documentation or something like that. And we won't specifically have like a very specific thing we're gonna go over per se, because it really depends on the question. That's one thing that just I've noticed is anytime I've started with a very specific curriculum, the questions I can never 100% predict. So sometimes that leads to very interesting discussions that one of the TAs might actually have really good insights into. And that could be an easy 10, 15 minutes. And I find that just having an agenda, just like a rough outline of these are like the goals that I want to get out of this like specific little time block versus like, all right, we are going to get through lines 8 through 24 of this specific doc. I'm still trying to figure out a way of phrasing that, but I just don't like the concept of like sticking really rigidly to a curriculum when by the nature of these classes, I just don't know what they're going to ask or what's going to be interesting to them because they can kind of shift around in terms of like experience levels. So I don't know if it's helping at all, but to me,
yeah, that answers that question, but then it prompts another one, which is how does that change the way you prepare your class? Because usually I prepare a number of slides and they have examples on them, and I mean that becomes the de facto curriculum, right? But you say that okay, we have an agenda and we're doing this, but you're still doing remote. How do you actually do that so that you're not sort of scribbling on the screen early Khan Academy style?
Gotcha. I would say that for when like the breakout rooms or when we do get on a discussion, I'll probably just open up like my terminal and just go over examples in there. Normally I'd say when it wasn't remote, I would just hop on a whiteboard and write it out. So I'm still figuring that out. But it might be something I just have to like define better. But to me, it makes more sense to like, all right, I have an agenda. We have these specific time blocks and I have an idea of what I want to go over that time block. But depending on the questions that are asked, we may or may not get to everything that's in there, but I'll still manage to get through it. I don't know if that makes sense.
Oh,
Yeah.
David, you're muted.
Yeah, thank you. It does. Thanks.
Great. Thanks, Melvin. Next, Zaki, can you unmute and ask your question?
Yeah, hi there. So my question was around, once a student goes to a class and they're done, they typically hit what is called the forgetting curve, right? They start forgetting all the stuff, right? There's like data about that, like the Ebbinghaus forgetting curve. So how do you create durability for the learner after the class or the course is done? And what would be what would be your recommendation for practices to build this kind of durability besides practice, right? So just trying to look at what else is out there that you've come across.
I mean, in terms of like durability and what keeps them like motivated and keeps them like remembering these things, it's like they're pretty well motivated in terms of like their junior devs trying to get their first dev job. So, if you tell them this concept, these paradigms are gonna like help you become a better developer. Also, like it'll help you understand languages that might pay you more for your first job. Then they're pretty inclined to want to stick with it. Um, but I find just giving them technical challenges like generally helps. I don't know if that's like the answer you're looking for, but in my experience, since they are junior devs coming like pretty much right out of a boot camp, then the durability part hasn't been an issue because they are very motivated to keep track of all these things, especially because they're spending 80 hours a week learning how to code and all that. So their retention's already like primed, if that makes sense.
Yeah. Okay. So do they after the class, like have you heard stories of some of them, where the student surpasses the teacher, right? Like some of your students, they've shared their lessons on how they built mastery, right? To some extent, right? No one's a true master, but some level of mastery as they progress through their journey in Elixir.
Oh, is there a question there? Sorry. Oh, what?
So sorry, I was just asking, just to follow up on that quickly. I don't want to hog the space. Just have you had any of your students come back and recommended, hey, after your class, I did this and this helped me really grok or assimilate the information and create that kind of durability? Do you have anything you could share with us?
Yeah, I've had two that managed to get their first dev jobs were in Elixir, and the thing that they both said was the Elixir class is created as intro, but they were just really interested. Like they found it super interesting, so they just did extra stuff like on their own. Because this class is just mainly meant as like an intro to just like functional concepts.
All right.
And just going to be a certain percentage of them that just become super interested, and then it's their jam. I'd say probably 80% of them don't really like come back with, or I mean, I say 80% of them aren't really going to be working in Elixir. That's just going to be a given. Most of them end up with Ruby jobs, which is fine. But the ones that have gotten like Elixir gigs or contracts, it seems to be that they're just super interested. Like that's just the one common variable between the ones that have like kept up with it. They fell in love with it. And I don't know from like a scaling standpoint if that helps. Probably
Okay.
not.
Yeah.
But that's just
Thank
been.
you.
Great, thanks. Sophie, hi. Are you available to unmute and ask your question?
Yep. Yeah, I think it's just taking a second to kick in. Yeah, first of all, thank you so much. This has been super interesting and there's a lot to think about. And I'd be curious to hear you elaborate a little bit on experiences teaching people who are either learning OO first or coming from an OO background versus folks who are coming to Elixir or a functional language as their first language. What are the different approaches or the things that you've noticed there?
I would say 99% of them have been starting in the whole OO world. Like, I don't think I've had a single one that's come like completely fresh. Other than like a 9-year-old that sat in once, and that was interesting to explain what arrays were and lists were. But with that being said, I think the biggest thing that helps them is just the concept of like the difference between a method and a function. That has been the one thing I would just hark on, like, hey, this string, you can't just invoke dot whatever on it because the data and the behavior are not coupled. And really drilling into that, I feel is like key. And I think it's something I guess like overlooked. Oh, what's the difference between a method and a function? But really diving in deep into that has been like really eye-opening, because for a while when I was first starting to learn how to code, I didn't know the difference. I would call a function a method a function. But actually when you get into the details of like, oh, a function, there's a module and it's got functions, and then you pass your data into it. Once you start coming up with examples and showing them that, and they can play around in like in the editor, and they start getting their error messages and whatnot, it seems to help people like get over that pretty quickly. Like this is just like a rule of law, you can't do this because of this. And then I think starting there helps transition a lot of the other things, because that's about as fundamental I think as it gets, if that helps. I don't know if that makes sense.
Great, thanks, Sophie. Good question. Next, we have Fonz. I hope I'm pronouncing that correctly. Fonz, can you unmute and ask your question?
Yeah, it's about the when the people is coming from, especially from objects, there are like two ways, or I have seen two ways, like going through directly the documentation for functional, or just start writing code. And when you just start writing code, it's usually that you bring some practices from non-functional languages. So how do you balance that, or how do you avoid to doing that?
Yeah. So I'd say like the first half of the class, first couple hours is like we're not really writing too much code other than me maybe showing some examples and explaining some of the rules of like difference between method and a function, why you can't do this, why you can't do that. But after 2 or 3 hours of like different examples and stuff like that, like I start off with like very, very basic like challenges, like, all right, find me all of the whatevers in this string. And then they'll just go off and they'll read the documentation on their own. And then they'll find the string module. Then the string module has functions. And then they'll just read through. And then they're pretty good at reading documentation at this point. So I would say these people are pretty proficient in OO and just like that whole area in general. So it's not like they're starting from scratch and they don't know how to navigate docs. And especially coming from like the Ruby docs, the Elixir docs are like a godsend compared to the Ruby docs. So it doesn't take them too long to like decipher them and figure stuff out. But I think it just comes down to having like a list of like, I don't know, 10 or 15 basic challenges, like technical challenges that go into the different data types, and having them just know like, all right, this is a list tech challenge, and why is a list different than an array? Because like naturally when they're trying to solve that problem, they'll start trying to use like the index notation, and then that doesn't work, which leads to the question of, oh, why don't we have index notation? So I'll kind of use the challenges as a way to like, I don't know, probe more questions, because of the patterns that they use aren't gonna work. So if you have specific challenges that you know the way that they would normally solve them isn't gonna work, then it just like opens up a dialogue. And during that dialogue between me and the TAs, we think of different ways of trying to explain these concepts of like, oh yeah, so you have to iterate through this list and recursively iterate through it, because your state's gonna be a thing, and it's trying to figure out how to, if I'm explaining this at all well. But I find that people generally understand documentation pretty well. And by the point that we get to the technical challenges, they are aware that a lot of their ideas aren't going to work. And when they don't work, they are more inclined to ask like better questions like, oh, what can I use? I know I can't use this, but where can I look to see an example? And they're pretty good at finding things on their own. I don't know if that helps or answers your question.
Yeah, great.
Thank you. Don, I know you said Sophie's question sort of covered the same territory as yours, but I'm wondering if there was anything in Melvin's answer that created a question for you. If you don't mind unmuting to let me know, and if you do have another question you could ask. If not, I can.
Well, no, I mean, I can just kind of follow up. So my son's turning 11 and I'm going to teach him programming. So I'm actually taking him through Sophie's book to teach him programming, any programming at the first time, mainly as a head fake, because he doesn't like to read. I never really liked to read as a kid either. So I'm just like, he wants to learn this thing. So if it's going to get him reading books as an 11-year-old, whatever it is, I don't care what it is, it's a good thing. So yeah, so I'm definitely curious on that, and I'll post back. But then also I know in our Denver Elixir group, we have like a beginner's track and then like an experience track, if you will. So we do one talk and the other, but actually we haven't really done the beginner's track a lot lately. So I volunteered to start with lists. I wanted to kind of do like a couple of those. So if you have any other suggestions, you did say kind of method versus function. Is it like another topic, and pattern matching? But if you have any other like, good things to put in that beginner track.
Yeah, declarative versus imperative. So when we're working with lists, like, the imperative way would be to write the recursive way of doing it and like showing all the recursion, or we could just use the enumerable. So just showing them like, hey, here's a list. This is what is happening underneath the hood. This is imperative, but the declarative would just be enum.map. And going into that, like I find really diving into declarative versus imperative, because people like they'll start noticing that the lists aren't behaving like arrays, and then they'll start asking questions about like so you have to use recursion to do this? How does the recursion work? And then I just tell them like, hey, there's an enumerable library that's already there that does this that you could just use. But if you really want to understand it, do it on your own time. But for now, we're going to take the declarative approach and just use these tools that are already here. I don't know if that helps.
No, that helps. Like I said, the first one is on list, and I brought it up in our Slack, and that's definitely something we want to talk about. Like, when do you use recursion versus using some of those built-in modules? And my kind of best answer is, like, for the most part, use enumerable, use lists, dot whatever. But then if you need to do something specific that's not covered by those, like you want to match the first 3 elements of a list and then traverse through a list in chunks like that, it's not something you can easily do with just reduce, right?
Yeah. That's an interesting one. I'm not sure.
That is great. And I am sorry to interrupt, but our time is up. And I know there are a few questions that were left unanswered. Hopefully, Melvin, people can find you elsewhere in the conference and continue the conversation. I know I still have a few that I will ask. And before you leave, I just wanted to remind you to provide constructive feedback, critical feedback, positive feedback about the presentations to the conference organizers. Visit the booths to support sponsors and join the Toucan Talks. It would be great to see everyone. Thanks.